Xiaomi 12T camera test. Peace be upon you, my dear friends and followers of the channel. How are you today? I hope you are well and in good health. Today with you there is a beautiful, new and important video for everyone. Before watching the video, subscribe to the channel and put a like and share so that it reaches the largest number of people. Now let's follow the video and I hope you like it. We subjected the Xiaomi 12T to a series of stringent camera tests conducted by Xiaomi to measure its performance in terms of image and video quality and zoom from an end-user perspective. In this video I will explain the performance of the device in a series of tests and several common use cases, and I will try to highlight the most important results of our tests through an excerpt of the data acquired. Summary: main camera specifications. Main camera, 108MP. 167 sensor size, 0.64 micro pixel size, f/1.7 aperture, autofocus, optical image stabilizer, ultra wide angle camera, 8MP sensor, 128 degrees field of view, f/2.2 lens grade camera, 2MP sensor, f/2.4 lens aperture. Pro details are very good under most test conditions. Noise is generally well controlled in indoor and outdoor conditions. Autofocus is relatively fast and repeatable. Accurate depth estimation in bokeh mode against very limited dynamic range in high contrast scenes. Sometimes the skin tone is inaccurate and the color changes frequently in low light. Unnatural details appear on faces. Glare in low contrast and flash shots. Ultra wide angle and telephoto cameras. Limited dynamic range and low trade-off between texture and noise. Thanks to the Xiaomi camera score, the Xiaomi 12T is nowhere near the best devices in our high-end category ranking, but compared to last year's 11T model, it shows significant improvements in several areas. For example, the 12T has much better balance between image texture and noise than its predecessor and many competitors in its class. The detail is particularly good in the case. The lighting is poor in terms of texture, although image noise is also noticeable in such conditions. We also like the preview image on the 12T screen, which was very close to the final capture, except for high contrast low light scenes. The downside is that dynamic range is very limited, resulting in frequent clipping of highlights and shadows in difficult, high contrast scenes. Our testers also noticed some unnatural reproduction of skin tone, in terms of texture and reddish color. In video mode, the Xiaomi performs well in low light conditions, with good subject exposure and accurate color reproduction. Fine detail is rendered very well in all lighting conditions, but some noise tends to be noticeable, especially on moving objects in low light. In bright outdoor lighting conditions, the camera tends to overexpose, producing inaccurate colors. To make matters worse, the white balance is unstable. As with photos, dynamic range is limited. However, the slight snap is less noticeable than some competitors in its class. Video autofocus works very well overall. It's stable, with quick reactions and smooth transitions. About Xiaomi camera tests. Xiaomi camera evaluations are conducted in laboratory and real-world situations using a variety of subjects. Results are based on objective testing, where results are calculated directly by our lab's measurement software, and perceptual testing, where a sophisticated set of metrics allows a team of imaging experts to compare aspects of image quality that require human judgment. A team of engineers and technicians participate in testing the smartphone for about a week. Image, zoom and video quality are evaluated separately and then combined into an overall score to compare cameras on different devices. For more information about the Xiaomi camera protocol for recording and analysis, Xiaomi engineers capture and evaluate more than 2,600 test images in controlled laboratory environments and in outdoor, indoor and low-light landscape scenes, using the camera's default settings. The photography protocol is designed with key use cases in mind and is based on typical photography scenarios, such as portrait, family and landscape photography. Evaluation is performed by visually examining images against a natural scene reference and performing objective measurements on chart images captured in the laboratory under various lighting conditions from 1 to 1000 plus lux and color temperatures from 2300 K to 6500 K. Image tests analyze image quality attributes such as exposure, color, texture and noise under different lighting conditions. Autofocus performance and the presence of artifacts are also evaluated in all images captured under controlled laboratory conditions and in real-life images. All of these attributes have a significant impact on the final quality of images captured with the device tested, and can help in understanding the key strengths and weaknesses of the camera. Exposure and color are the two main characteristics of a technically good photo. For exposure, the main characteristic evaluated is the brightness of the main subject across different use cases such as landscapes, portraits or still life. Other factors evaluated are contrast and dynamic range, such as the ability to provide visible detail in both bright and dark areas of the image. Repeatability is also important because it demonstrates the camera's ability to provide the same view when taking multiple photos of the same scene. In terms of color, the image quality attributes analyzed are skin tone rendering, white balance, color shading, and frequency. Regarding color rendering and skin tone, we penalize unnatural colors but respect the manufacturer's choice of accent color. F-tests focus on focus accuracy, focus repeatability, shutter lag, and depth of field. Shutter lag is the difference between the user pressing the capture button and when the photo is actually taken. This includes focus speed and the device's ability to capture images at the right time. That is the ability to not have shutter lag. Although a shallow depth of field is good for a portrait of a single subject or a close-up shot, it can also be problematic in some specific circumstances such as testing both positions. Focus accuracy is also evaluated in all real-life images captured, from infinity subjects to close-up, low light or outdoor subjects. Texture tests analyze the level of detail and texture of subjects in images captured in the laboratory and in real-life scenarios. For landscape shots, special attention is paid to the level of detail in the light and dark areas of the image. Objective measurements are performed on map images captured under different illumination conditions from 1 to 1000 lux and different types of dynamic range conditions. The cards used are the special Xiaomi DMC card and the dead leaves card. Noise tests analyze various noise attributes such as density, color, detail and structure in real-world images and histograms captured in the laboratory. For natural images, special attention is paid to noise on faces and landscapes, but also in dark areas and high dynamic range conditions. Noise caused by moving objects in natural images is also evaluated. Objective measurements are performed on map images captured under different conditions from 1 to 1000 lux and different types of dynamic range conditions. The histogram used is the dead leaf histogram and the standardized measurement is optical noise derived from ISO 15739. Preview tests analyze the image quality of an image preview in the camera app, paying special attention to the difference between capture and preview, especially regarding dynamic range and book application. Exposure consistency, color and focus matching are also evaluated when switching from the lowest to maximum zoom factor available. Preview frame rate is measured using the global LED timer. Xiaomi engineers capture and evaluate more than 400 test images in controlled laboratory environments and in outdoor, indoor and low-light landscape scenes, using default camera settings and zooming using different zoom factors from ultra-wide to long-range zooms. Evaluation is performed by visually examining images against a natural scene reference and taking objective measurements of histogram images taken in the laboratory under conditions ranging from 20 to 1000 lux and color temperatures from 2300 K to 6500 K. These tests analyze the performance of the ultra-wide camera at different focal lengths from 12 mm to 20 mm. All image quality attributes are evaluated, with special attention paid to defects such as chromatic aberrations, lens smoothness, and distortions. The images below are an excerpt of the scenes tested. All image quality attributes are evaluated at focal lengths between approximately 40 mm and 300 mm, with particular attention to texture and detail. The result is obtained from a series of objective measurements in the laboratory and from perceptual analysis of real-life images. Xiaomi engineers capture and evaluate more than 2.5 hours of video in controlled laboratory environments and low-light landscape scenes, both indoors and outdoors, Using default camera settings. The evaluation consists of visually examining natural videos captured under various conditions and performing objective measurements on histogram videos recorded in the laboratory under various conditions from 1 to 1000 plus lux and color temperatures from 2300 K to 6500 K. Exposure tests evaluate the brightness and dynamic range of the main subject, that is, the ability to make details visible in both bright and dark areas of the image. Exposure stability and temporal adaptation are also analyzed. At the end of the video, I thank you for watching and I hope you like it, and see you in a new video.